Hi friends, in this video I am going to explain metal forming, which is a production technology topic. So first we want to know what is metal forming. So in metal forming we are going to deform the metal and we are going to get the required product. So you know the basic metal forming operations are rolling, forging, extrusion and wire drawing. These are the different metal forming techniques which we are using to get our required product. So first let me explain what is this stress strain curve represents. In this stress strain curve, this point is known as sigma y and this region is known as sigma u. This sigma y is yield strength and this sigma u is ultimate strength. And this region is known as metal forming region. This region is known as metal forming region. Metal forming region. So why we are calling this metal forming region means if we apply load beyond yield strength, if we apply load beyond yield strength, the material starts to deform and we are going to get the required product. So up to this point, up to sigma y, that is up to sigma ultimate strength, whatever stress we apply, if we leave that stress, the material will come back to its original position. That is, this is an elastic region. So if you applied the yield strength up to sigma yield, the material will come back to its original position. So beyond that, if you apply a sigma, if you apply stress, the material will starts to deform. Let this will be epsilon 1 and this is epsilon 2 and this is, so whenever you are applying a stress beyond this, the material will starts to yield. So this is known as metal forming region. This sigma u is known as ultimate strength. If you apply stress beyond this, the material will start break. This is known as necking region. This is known as necking region. So the metal forming region starts from yield and ends with ultimate. If you give the stress beyond ultimate, then the material starts to break. So this is the general operating region. So this is the general operating region. So in this case, I'm going to explain you the difference between a hot working and a cold working. So first, what is hot working? Everyone knows that in hot working we are going to increase the temperature, but in cold working we are not going to increase that, everyone might be knowing. So what happens if, so my aim is to increase this region, right? So this is the metal forming region. I want to increase this region so that I can deform the material as much as I can. So how can I increase the region? I can either decrease sigma y or I can increase sigma u. Let me repeat. I can decrease sigma y or I can increase sigma u so that this region increases. So that is favor for me to do a metal forming. So how can I increase sigma y? Sigma y is an yield strength. Suppose, for example, if I increase the temperature, what happens to the strength of the material, metal? It decreases. So if the strength of the like if temperature, if we increase the temperature, what happens to its strength? Its strength decreases, that which means we can deform the material very easily. If we increase the temperature, strength decreases so that we can deform the metal easily. So if temperature increases, what is the strength? This strength is represents sigma y. So this sigma y decreases so that I can easily increases the easily deform the material. This is hot working. So what in case of cold working? If I increase the, if I decrease the temperature, what happens is sigma u increases. So if I decrease the temperature, what happens, sigma u increases so that again the area increases, the metal forming region increases. So it is, but here it is very difficult. Now I am going to explain you the difference between the hot working and cold working operations. In hot working, we are going to increase the surface temperature. If we increase the temperature, what happens is oxidation take place. What is oxidation? Air comes in contact with the higher temperature metal so that there will be a oxidation takes, metal oxides will be formed, so the surface finish will be low here. In cold working, I'm not going to increase the temperature, so there is no problem of oxidation, so the surface finish will be good. So second thing is in power required. I here, due to the less strength of the metal, I don't want to give more load to deform. So here I am going to give only less load so that the power required will be less. In cold working, ultimate strength will be increasing so that I want to give more load to deform the material. So here power required will be more. What is tool life? In tool life, so since the material, since the deforming material is strength is very low, so it can be easily deformed. So in this case, the tool life will be more. Like in rolling operation, we will be using two rollers. These rollers will be used to deform the material. So the entering material definitely having the less strength in case of hot working. So this roller can easily deform, so the tool life will be more. But in hot working, since the strength is more here, this will be giving more force to deform, so the tool life of this material will be less. So obviously we want to operate in a higher temperature, so the setup cost of the material will be high. Oh no, there is no increase in temperature, so setup cost will be low here. Or dimensional, since we are increasing the temperature in strength of materials, we will be knowing the thermal stress. So if the temperature increases, the thermal, due to thermal stress, that is contraction or expansion takes place, so the dimensional stability will be low when you increase the temperature. That is hot working. Here there is no problem in dimensional stability. Here, dimensional stability will be good here. So ductility, what happens if we increase the temperature? Ductility increases, which means I can easily deform the material. Here the ductility decreases, means I have to give more force to deform the material. As the ductility increases, strength decreases, that everyone knows. As the ductility decreases, the here the strength increases. This is the thing I want to explain, and this is the key difference between the hot working and cold working. And one more point I would like to give. uh, Many materials are brittle in nature. Many materials are brittle in nature. Due to brittleness, I cannot yield the material easily. So, in for brittle material, there is no such difference between sigma u and the sigma y. Sigma u is a necking region where it will break. Sigma y will be yielding. So there is no such difference between sigma u and sigma. It is almost same. So I cannot do this work in cold working. So what I will be doing is I will be increasing the temperature of this material. Due to the increasing temperature of the material, what happens? The ductility increases. So ductility increases. So now I can apply a load. Now I can deform the material. So this is the one important point in hot working. So let me explain. In cold working, we the operating range, that is the working range is less than zero point 0.3 times of Tm. Tm is melting point temperature. In hot working, we will be, the working temperature will be greater than 0.65 Tm. That is, this is the recrystallization that is, we are working above the recrystallization temperature in hot working, below the recrystallization temperature in the cold working. Thank you.